6A, roots and radical expressions. So some of this is a review from things you learned in Algebra 1, and then we're going to take it a step further. Okay, so the nth root. We've done mostly square roots and cube roots. Now we're going to look at, we can take any number root, so a 4th root, 5th root, 18th root, all kinds of different things. So the parts of a root. Okay, so the number inside the root part is called the radicand. Alright, and n, or the number that we're actually taking the root, that's called the index. So if it's the 3rd root, the cube root, the index is 3. If it's the 5th root, the index is 5. Okay, and here you see the rules for answers. If n is an odd number, there's one real root, and it doesn't matter, the radicand can be positive or negative. So we can take the root of negative numbers if the index is odd. Alright, and then if the index is even, it's positive and negative. So just like last chapter, anytime we did the square root, we had to say plus or minus. Alright, and you cannot take even roots of negative numbers. Alright, so we're going to use a calculator. Alright, what are the real cube roots of these three numbers? I'm going to pull my calculator up. Two different ways to type, well, 3 different ways actually to type cube root in your calculator, probably only 2 that you're going to use. Cube root is above the parentheses, so you can do it that way. So the cube root of 0.008, whoops, too many zeros, 0.008 would be 0.2. The other way, and this is the way you're going to do all roots other than 2 or 3, is this little x root right here above the caret button. So you're going to put the root in first. So if it's a cube root, it would be 3, and then I would do this root, and then I want negative 1,000. So that would give me the cube root of negative 1,000, and that would be negative 10. Alright, and then cube root of 1/27th. 1 over 27, and I get 1/3. Alright, so what are the real 4th roots? So same thing, and this time we're going to use that little x root because we don't have a 4th root button out here somewhere. So 4 root of 1. So the 4th root of 1 is, of course, just 1. Okay, the 4th root of negative 0.0001. Now, I'm going to go ahead and do it, but you cannot take an even root of a negative number. So if I do it, my calculator is going to tell me error. Alright, so there is no real solution. Alright, we know there is an I solution, but for these it's good enough to just say no real solution. Alright, and then last thing I need is, oops, let me clear this, 4th root of 16 over 81. And that would be 2 over 81. Alright, and this is a point where how you enter things in your calculator is important. So 2 over 81, that answer really doesn't make sense, because why is the 81 still the same? And the reason is when we put it in our calculator, we need to make sure that we're putting that fraction in parentheses. So before, the calculator just took the 4th root of 16, didn't include the 81, so I'm going to put that in parentheses. And my answer here is actually going to be 2/3. Okay, simplifying square roots and cube roots. This is something you did in Algebra 1 and we reviewed earlier. So you have 2 methods here. You can use perfect squares. So 9 is the largest perfect square that you can divide 54 by. And the square root of 9 is 3, so it's 3 square root 6. Or you could use your factor trees, and we're circling pairs. So the pairs go outside and what's left over is inside. Same thing here for for simplifying cube roots. So we can do perfect cubes. Alright, and find the biggest perfect cube that it can be divided by, or we can use our factor tree, and when you're looking for groups of whatever the index is. So I have a group of 3 3s, that's why the 3 is outside, and then I'm left with cube root of 3 on the inside. So now what happens when we get larger roots? Well, same thing, okay? You could still look for the something that is a 4th root that you could divide 96 by. Alright, so I can say 2 to the 4th is 16, and 96 can be divided by 16. So it'll be the fourth root of 16 times the fourth root of 6, and the fourth root of 16 is 2, so I have 2 fourth root 6. Okay, so we can still do it with perfect whatever the index is, or we can do factor trees. So I could do 96 and split it apart. 96 is 8 times 12, and then I could break 8 apart into 4 and 2, and then 4 apart into 2 and 2, and then 12 is 6 and 2, and 6 is 3 and 2. So I have these, this, this. Those are my numbers, and I'm looking for groups of 4. So I have 1, 2, 3, 4 2s. Alright, so that would mean 2 would go on the outside. And then on the inside, I have a 2 and a 3 left, and 2 times 3 is 6. So basically, when we do the factor trees, we're looking for groups of whatever the index is. So what I want you to do is pause here and try this example, and then come back and see if you got the answer that I have. Alright, so if we break 64 apart using a factor tree, and then I'm looking for groups of 5, so here are 5 2s, that goes on the outside. I have 1 2 over here left over, so that goes inside my root. Okay, and then simplifying radicals. So again, this is something you did in Algebra 1. A couple different ways that you can look at it or think about it. I'm going to show you some, and then you pick the one that makes the most sense to you. So simplify a to the 10th, the square root of a to the 10th. So here we wrote out 10 different a's and circled groups of 2, and there are 1, 2, 3, 4, 5 groups. So a to the 10th, the square root of a to the 10th would be a to the 5th power. The other way to do it is just to divide by whatever the index is. So if I have a square root, my index here is 2. 10 divided by 2 is 5. Okay, when you have something that doesn't work evenly, okay, again, you can draw this. So there's 7 n's here. There are 3 groups of 2, so that would be n to the 3rd on the outside, and I'm left with 1 on the inside. Or you can rewrite it as an even number. So n to the 7th would be the square root of n to the 6th times the square root of n. And then this is an even number, so I just divide by the index. So 6 divided by 2 would be 3. And then I'm left with an n inside the square root. Okay, so either way you want to do it there, depending on what the exponent is here, you might not want to write out all of those letters, but if the division part confuses you a little bit, then you might need to. So here we have the cube root of x to the 7th, so we're looking for groups of 3. So I want a number less than 7 that is divisible by 3. So I'm going to rewrite this as the cube root of x to the 6th times the cube root of x, because that gives me a total of 7 x's, and 6 is divisible by 3. 6 divided by 3 would be 2, so this would be x squared on the outside, and then the cube root of x on the inside. Okay, or if you want to just write them all out, there would be 7 x's, 3, 4, 5, 6, 7, and I'm looking for groups of 3. So there's a group of 3, and there's a group of 3, so I have 2 groups of 3, and 1 x left over. Alright, so same thing here. I want you to pause, try this example, come back, check your answer. Alright, so it should be b squared times the 4th root of b squared. I wrote the work out both ways. Okay, if you're not understanding this, make sure you circle this or put a star here so you can ask me about it in class. And we have just one more thing to look at, and that's simplifying things that have numbers and variables together. So this is the cube root of 40, a to the 4th, b to the 8th. So I'm going to look for perfect cubes that 40 can be divided by, and that would be 8. So I'm going to have the cube root of 8 times the cube root of 5. And then with the variables, I'm going to break them apart by multiples of 3. So a to the 4th becomes the cube root of a to the 3rd, because that's a number that's divisible by 3, and then I have 1a left over. B to the 8th would be the cube root of b to the 6th, because 6 is divisible by 3, and I would have 2b's left over. Alright, then I'm going to take the cube root of anything that I can. So the cube root of 8 is 2. The cube root of a to the 3rd is just a. The cube root of b to the 6th is b squared. Alright, and then these things that I cannot simplify stay inside, so I have 5ab squared on the inside, and this would be my final answer. Alright, so I want you to try this last one here.